So hi guys, today we are going to talk about an algorithm. So let's go into programming modus. So we are going to talk about how to draw lines. So let's start with the beginning. As you know, a computer has a screen and that screen has pixels, unless you have a vector screen. But that's really unlikely. So pixels. And to display things on your screen, the pixels change their color. Now today most computers have a size of 1920 by 1080 pixels, but that's too much to explain things properly, so we are going to work with an imaginary screen with 16 by 9 pixels. So let's say you want to draw a line from Mario to Luigi. I have 3 algorithms to do this, but the line needs to have a slope between -1 and 1, that's from here to here. Let's begin with the first of 3 algorithms. So first we are going to need 4 variables called x, y, a and b. I assume that you know the basic equation of y is ax plus b, because we are going to use that. First we calculate a and b, and we make x and y the coordinates of Mario. Then we are going to iterate over every x between Mario and Luigi, and for every x we calculate y and convert this to an integer, because there is no pixel that has a decimal number in the coordinates. Then we color the pixel. Now this algorithm looks like this. For every x between Mario and Luigi, y is ax plus b, convert y, and color ax. There you go, that's my algorithm.
Okay, that's not a good algorithm.
No, this is not an efficient algorithm, but it's an algorithm. Let's make it more efficient, because this is super inefficient. This code has a lot of big calculations, including a multiplication, which is very time sensitive. So this algorithm is not good, because it does these calculations for every pixel. So nope, not a good idea. Let's look at another method. Now this next method has a name. It's called the Digital Differential Analyzer, DDA for short. This algorithm makes the calculations far less heavy by calculating a from the y is ax plus b formula and adding this to the previous y. So now it goes to every x between Mario and Luigi, and it just adds a to the previous and then converts it to an integer. Now this algorithm looks like this. For every x between Mario and Luigi, y is ax plus b, convert y, and color ax. Now this is also not a perfect algorithm, because it still has to convert y for every pixel. Well, the next algorithm solves this problem, the Bresenham algorithm, or the midpoint line algorithm. These are not entirely the same algorithm, but they have the same idea written down a little bit differently. Both of these algorithms can only handle lines with the slope between 0 and 1. So imagine having a pixel and the computer wants to draw the next pixel. Since your slope is between 0 and 1, your next pixel can be in 2 places, here and here. Therefore, y is going to stay the same, or change into y plus 1. To determine this, we take a decision variable, d. Now we have our function, y is ax plus b. When we put this in another way, we can make 0 is ax minus y plus b. And since a is dy over dx, we can use math? Yes, we can use math, because we can use math to become 0 is dy x minus dxy plus dxb. And dy and dx and b are variables we can calculate beforehand. So we have a function that is 0 on one side for every point on the line. We can use this formula in our algorithm. But how, you might ask? Well, first, change the 0 to our decision variable from before, and we have a decision formula. This is because when we fill in a point in our algorithm, we get a number. When our number is smaller than 0, the point is above the line. And if our number is bigger than 0, then the point is below the line. Pew! Mind blown. Do you see where we are going? No? Well, remember the choice we had between y and y plus 1. Well, if we calculate d for this height, which is y plus 0.5, we can determine if this is below the line or above the line. If this is below the line, we can take y plus 1, and otherwise we can take y. Now, if we know the previous decision value and whether or not the y value changed, we can convert our function to d is previous d plus dy minus dx when the y changed, or d is previous d plus dy when y did not change. Now we have no multiplications and no conversions in this algorithm. This algorithm looks like this. First we calculate d, and then for every x we look at d, and if it's smaller than 0, then we do d plus dy, and if it's bigger than 0, then we do d plus dy minus dx, and we change the y. This is a great algorithm, but we can do even better, because now we do 3 additions for each pixel. Because if we calculated a pixel and our y didn't change, our next d will be d plus dy. If the pixel did change, our next d will be d plus dy minus dx. If we calculate dy minus dx beforehand, that is again 1 addition less. Yay, that's even less calculations. Now Bresenham writes it like this, because it's less code. But essentially they do the same. So, is this a good algorithm? Yes, it has only a few calculations, no conversion. Yay, we did it! Huh? Wait, what is this? What? No, a circle! So hey guys, thanks for watching. I have worked really hard on this video, so I hope you like this video. I'm not gonna be able to make a video like this like every 2 weeks, but I'm definitely going to make a part 2 of this video. So maybe subscribe for that. See you in the next video. Bye!